Design of light gauge steel frame for building structures with FRAMECAD Structure. A tutorial series by engineer Siraj Biswas. Chartered Engineer, Institute of Engineers, India. Gold medalist in engineering stream, University of Mysore. M.Tech in Structural Engineering, IIT, Delhi. Sun Certified Java Programmer, Sun Microsystem, USA.
In this section, we shall create the LGFS wall panel at first floor level, that is above the level of 3.5 meter above the concrete deck slab top of first floor. So for that, copy the ground floor layout, copy and select a base point and place it on a side border frame. So if we look at the first floor layout, architectural drawing, this is the first floor plan of the architectural drawing. If you look at it, you can see there is a recreation part at the first floor, which is having a guitar span almost 8 meter center to center span. So there is no wall here at this portion. So we need to remove all this wall from the layer we have copied from the ground floor. So let us remove those walls. These are our walls which are to be removed. Now let us change the base level of all these walls and list command LOI, enter. So LI, enter, select a wall and select all other wall. Here our base level is at 3.5, reduce level of the base of the wall is 3.500. Amend. So do we want the updated height of the maintain same top plate? No, there is a gap above the wall, so we should click no, then amend. Now among this wall, many of the wall will not remain load bearing, so you have to change those wall as a non-load bearing. So let us list those all. LI list. This wall and this wall, this wall and this wall shall not remain load bearing. So, enter. Loading information, make it non-load bearing. Amend. So these also have become non-load bearing. So You have to change the relative level of the beam. These beams are not there at the roof level. This beam is also not there at the roof level. This beam is also not there at the roof level. So these beams will not be there at first floor level. So we can see the columns. These columns can be seen at the first floor level. So you have to change the top RL of this beam. So 3500 plus 34 3050 06550. So let us list this beam also. Li list 6550. Amen. So let us check this beam list. Okay. So this is our first floor level. If you see, these ventilators are not there now. So delete this, delete this, delete this, delete this. We have to change the level of this waved beam as well. So list this beam. So top RL will be again 6550. Amend. Let us, we have deleted those ventilators. Let us join these two panel, this and this. Now let us make a mirror of this opening. We're taking a line. So that we can mirror this opening. So MI mirror, select the opening, enter, take the mirror, drop perpendicular to the wall. So the mirror is created. These columns ends at the first floor level, so we'll extend this wall up to this wall, extend ME. So this is the wall that is to be extended up to this wall. We need to extend this wall and where door is there, so let us do one thing. Let us join these two panel, MJ, this and this. So this panel has been joined, and MJ, this and this. So now there is another level having cantilever beam from the columns. So let us copy these walls, take the base point and take it here. Read this opening as well. Now let us list this beam. Actually speaking, we need to have this beam here as well. So let us copy this beam again. CO copy, copy this beam on this beam and this beam. Take base point as the reference point. Place there. We have to see what is the top of this RL of this beam. Top RL of this beam is 5066. So we shall list this beam as. We do not have this wall here. It is coming from the mid landing level. We do not have this wall here as well. So LI list. Beam top RL is 5066. So we do not need these dimensions as of now. These two wall at first floor level shall have a height of 13. Let us check the height. It should be 1300. So these two wall should have height of 1300. List this two wall. 1300. Reduce level is at 3500. No. Amend. List. So mistakenly change the height of this beam 1384. I mean list. No, 1384. I mean this is actually ground floor level. We should have changed the wall height. List here. List. So this should be 1300 at first floor level. Amend. So and these walls all will have a height of 3050. LI list list, 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 list. Three zero 50 amend. These walls at landing level above the top level cantilever shall have a height of 1484 and reduced level shall be 5066. So let us list them and set it. Li list, set them as reduce level 5066, 5066, no 1484, amend. These three walls showing a start mark actually has a reduced level at starting point at 3400. So let us amend it. Now at top cantilever level of the MS structural beam, the beams are at the columns of 150 mm terminates. So we have to extend this wall by 150 mm. I have already drawn a line to show the line of termination of this wall. So let us take an offset of 150 mm. Now let us extend this wall panel by 150 mm. So ME is the command. Now select the entity to extend to. So we shall select this enter, then select the entity to extend, and again ME, select the entity to extend to, then select the entity to extend command. So both this wall has been extended. Now we delete this line. So let us check this. Enter 1484. First floor level, at this wall level we would like to have a wave beam. So let us draw a line, then go to add command, beam. So ours is a wave beam, waved. So top RL reads 6550 and the depth out of beam we can take as 350 here because beam height is 89. Create from point to point, point to point. So this wave beam has been created. Let us match the properties with this beam. We do not require as of now to match the property. So now let us list this wave joist. So in length and height we provide a lap of 89 mm on both sides, and then let us amend it. So if we see the 3D model, there is some problem seems in these walls and these walls and these walls. So let us check in the layout. So Li. So wall height has been given as 3150 instead of 3440. This is a typical mistake during generation. So let us change this list. Li list. Three zero 50 amend. So this wall has been amended. Let us go to the 3D model again. E3D. Note the base RL of this here. Most of the wall is at top of the bottom slab level. So let us go to the section. So this is also slab bottom is also at 3.5 level from the grade slab level. So reduced level of the wall shall be 3500. Now if we add 3500 plus 3050, that become 6500. Note at times the base levels doesn't changes with individual selection, collective selection. So the 3D model is showing that those discrepancies. So we have to go one by one and set the base level of each wall at 3500. Wherever required. Here at the first floor level, almost all of the wall have a base level, base reduced level at 3500 mm. So let us select one of the wall list, Li list. Go to command bar, Li list. So see, it has become 3400. So let us make it 3500. No, amend. So in the similar process, we need to check each and every wall and keep on checking the 3D until we get a proper 3D. After checking base level and the top wall height of each wall, let us, by the process I have described, let us go to 3D model view, in which you could see the 3D model, T3D, then J3D, enter. So the model looks fine now. All levels are seems to be okay. Now let us go back to the layout. With this, we complete leveling of making of first floor wall panel layouts. Next section will draw the trusses. So as per the section, there is a gable end, but the gable end truss have a parallel core truss. How to make a parallel core truss, we would have a look at that. So we save the model, file, save, and close the model.